Every summer, in gardens across suburbs, small farms, and backyard beds, the same quiet disappointment appears near the edge of the soil. A tomato plant that looked strong in June begins to fade in July. Its lower leaves turn pale, its stems lose their lift, and the flowers that opened a week earlier dry up before they can become fruit. A pepper plant beside it stops growing altogether, as if some invisible signal has told it to conserve whatever strength remains. Most gardeners know this moment. They stand above the plant, look at the yellowing leaves, and assume the season has already made its decision. Maybe the heat was too strong. Maybe the soil was poor. Maybe the plant was weak from the beginning. So they reach for the shovel, pull it out, and toss it onto the compost pile. But a plant that looks finished is not always dead. Sometimes the roots are still alive. Sometimes the stem still carries water. Sometimes the plant has not reached the end of its life at all. It has simply reached the end of what the soil can give it quickly enough. That difference matters, because a struggling plant is often not asking for everything. It is asking for one missing piece at the right moment. A mineral it cannot reach. A microbial system that has gone quiet. A nitrogen shortage that slows every new leaf. A magnesium gap that weakens chlorophyll. A soil rhythm that has been interrupted by heat, watering mistakes, or exhaustion. Modern gardening often turns this problem into a product. A yellow leaf becomes a bottle. A stalled flower becomes a bag. A tired bed becomes another trip to the garden center. But many of the fastest liquid feeds a gardener can make do not begin on a store shelf. They begin in the kitchen, in the bucket, in the scraps most people throw away before they ever realize those scraps still contain the exact materials a plant is missing. This is not because kitchen waste is magical. It is because plants and kitchens are connected by the same cycle. The onion skin, the rice water, the bruised tomato, the banana peel, the coffee grounds, the aged manure from a small farm animal. Each of these materials still carries nutrients, sugars, minerals, or microbial food. Left whole, they decompose slowly. Transformed into liquid, they can enter the soil system much faster. That is the hidden idea behind these 5 liquid feeds. Each one solves a different problem. One gives a quick mineral extract. One wakes up soil microbes. One delivers nitrogen from green scraps. One combines kitchen minerals into a broader tonic. And one reaches back to the oldest fertilizer system human beings ever used. The first begins with something almost everyone throws away without thinking. Onion skins. Every kitchen knows the sound of them. Dry, papery layers peeling off into the trash before the knife ever reaches the bulb. They seem too thin and too brittle to matter, as if the useful part of the onion begins only once the brown outer layer is removed. But those skins are not empty. They are protective tissue built by the plant to shield the bulb from sunlight, drying, pests, and disease. Because of that role, they contain concentrated minerals and plant compounds that do not vanish simply because the onion has reached a cutting board. The important part is not to bury them and wait. That is the mistake many gardeners make. They hear that onion peels are good for plants, dig them directly into the soil, and expect a weak plant to respond quickly. Eventually, those skins will break down. But dry plant fibers do not release their contents overnight. They need moisture, microbes, and time. A plant already collapsing in summer heat may not have that time. The faster method is extraction. A handful of dry onion skins placed in a jar of water begins releasing its soluble compounds the same way tea leaves release color into a cup. Within a day, the water shifts from clear to golden. After another day, it deepens into amber, carrying small amounts of minerals and protective plant compounds that were locked inside those papery layers. This liquid is not a complete fertilizer. It will not rebuild dead soil by itself, and it will not rescue a plant whose roots have already rotted away. But for a plant under mild mineral stress, especially one still holding life in its stem and root system, onion peel water can act as a gentle first response. It enters the soil without the harshness of a synthetic shock. It gives the plant a small drink of dissolved minerals. It gives the root zone something useful before the dry skins would have decomposed on their own. And sometimes that small difference is enough to keep the plant moving while the rest of the soil system catches up. The method is simple. A loose handful of clean onion skins goes into a jar or small bucket, covered with water, and left for 24 to 48 hours. When the liquid turns amber, it is strained and poured at the base of the plant, not sprayed across the leaves and not concentrated into a strong brew. The strength of this method is its gentleness. It does not force growth. It does not flood the soil. It simply takes a material that would have disappeared into the trash and returns part of it to the root zone in a form the garden can use sooner. And that is why onion peel water is the right place to begin. It shows the principle behind all 5 feeds. The value is not just in the ingredient. The value is in the transformation. But onion peel water mostly gives the plant a small mineral assist. The next liquid works differently. It does not feed the plant first. It feeds the invisible system around the plant, the living layer of bacteria, fungi, and microbes that decides how much nutrition the roots can actually receive. And it begins with cloudy water most people pour straight down the drain. The second liquid feed begins with something so ordinary that most people do not even think of it as waste. It is the cloudy water left behind after rinsing rice. In kitchens across the world, this water appears almost every day. It turns pale and milky as starch washes from the surface of the grains. Then it disappears down the drain before anyone stops to wonder what it still contains. Fresh rice water is already mildly useful because it carries starches, small amounts of minerals, and traces of B vitamins from the rice surface. But the real value begins only when the water is not used immediately. It begins when the water is allowed to ferment. At first, the change is quiet. The jar sits on a counter, covered loosely, looking almost exactly the same as it did the day before. Then, after 2 or 3 days, the smell begins to shift. It becomes slightly sour, not rotten, not foul, but alive in the same way that sourdough starter or fermented vegetables carry a faint tang when microbial activity has begun. That smell is the signal. The rice water is no longer just cloudy starch suspended in liquid. It has become a simple microbial feed shaped by wild yeasts and lactic acid bacteria that entered from the rice, the air, and the container itself. This is why fermented rice water belongs in a very different category from ordinary kitchen scraps. Onion peel water works mostly by extraction, pulling useful compounds out of dry plant tissue into liquid. Fermented rice water works by cultivation. It uses starch as food for microorganisms, and those microorganisms become part of the value of the feed. This idea connects to a larger agricultural tradition. In the late 20th century, Japanese agricultural scientist Teruo Higa helped popularize the concept of effective microorganisms, often shortened to EM. His work focused on beneficial microbial communities that could support soil processes, improve decomposition, and help restore biological activity in depleted soils. Homemade fermented rice water is not the same thing as a controlled EM formula, and it should not be treated as if it were a laboratory product. But it follows a similar biological logic. The gardener is not simply adding nutrients. The gardener is feeding life. When diluted fermented rice water reaches the soil, the microbes and remaining starches interact with the existing organisms around the roots. That narrow zone of life, the rhizosphere, is where much of plant nutrition is actually negotiated. Roots release sugars. Bacteria and fungi respond. Minerals become available or unavailable depending on microbial activity, moisture, and chemistry. A tired plant growing in biologically weak soil may have nutrients nearby and still fail to use them properly. The pantry may be full, but the kitchen is closed. Fermented rice water helps reopen that kitchen by giving the soil microbiome an easy source of energy and a small pulse of microbial activity. When the soil organisms respond, they begin breaking down organic matter more actively, releasing enzymes and reshaping nutrients into forms roots can absorb. This is why the effect of fermented rice water is often slower than a direct nitrogen feed, but deeper in its influence. It does not usually create a dramatic overnight transformation. Instead, over several days, the plant may begin to look steadier. The leaves hold themselves better. New growth appears less pale. The soil surface may even begin to smell more earthy after watering, a sign that biological activity is returning. The common mistake is using rice water too early. Many gardeners rinse rice, pour the cloudy water straight onto the soil, and expect the same result they heard about from fermented rice water. Fresh rice water may help a little, but it has not yet gone through the microbial transformation that makes the method interesting. The second mistake is using it too strong. A fermented liquid that smells sharply sour or has sat too long can irritate delicate roots, especially on seedlings or plants already weakened by overwatering. This is why the safer method is always dilution. A simple approach is to collect the water from rinsing rice, place it in a clean jar, cover it loosely so gas can escape, and leave it at room temperature for 2 to 5 days. Once it smells faintly sour but not rotten, dilute it heavily with plain water before pouring it at the base of established plants. The goal is not to soak the garden in sour liquid. The goal is to introduce a gentle biological nudge. Used correctly, fermented rice water becomes one of the simplest ways to remind a tired soil that it is supposed to be alive. It takes something that would have vanished into the sink and turns it into microbial food, returning energy to the underground community that supports the plant. And that distinction matters, because not every struggling plant needs minerals first. Some need the soil around their roots to wake up again. Some need bacteria and fungi to restart the quiet work of unlocking what is already present. But there are moments when a plant does not have time to wait for the soil system to rebuild slowly. A tomato losing color in the middle of the season, a squash plant dropping leaves, or a pepper that has stopped producing new growth may be missing one of the fastest-moving nutrients in the garden. That nutrient is nitrogen, and the third liquid feed begins with the soft green scraps most households throw away every week. The third liquid feed begins in the part of the kitchen most people try not to look at for too long. A soft tomato at the bottom of the drawer, a handful of wilted spinach, a cucumber that has lost its firmness, a few lettuce leaves that turned limp before anyone used them. Most households treat these scraps as the end of the line. If they are lucky, they go into a compost bin. If they are not, they go into the trash, then into a landfill where their nutrients are removed from the garden cycle completely. But to a gardener, those scraps are not useless. They are unfinished fertility. Green vegetable waste is rich in moisture, minerals, and nitrogen-bearing compounds that once helped living plants build leaves, stems, and cells. When those materials are buried whole in the soil, they can eventually return nutrients to the ground. But that process takes time, and time is exactly what a collapsing plant may not have. This is where liquid digestion changes the story. By crushing soft green scraps, submerging them in water, and allowing microbes to break them down before application, the gardener speeds up a process that would otherwise unfold slowly in a compost pile. The plant tissue begins to collapse, cell walls rupture, and nutrients locked inside the scraps begin moving into the surrounding liquid. The result is not elegant. It is not the kind of garden input that looks good in a glass bottle with a clean label. It becomes dark, cloudy, and strong-smelling because decomposition is not a decorative process. It is biology dismantling one form of life so another form of life can use it. And the main nutrient this method is often used for is nitrogen. Nitrogen is the nutrient most associated with leaf growth, stem expansion, and the deep green color of vigorous plants. When nitrogen runs low, plants often slow down dramatically. Older leaves may yellow first. New growth becomes weak and the plant appears to lose momentum even when water and sunlight are available. This connects to one of the most important ideas in plant nutrition, Liebig's law of the minimum. The principle is simple. A plant does not grow according to the nutrient it has in abundance. It grows only as far as the most limited essential nutrient allows it to grow. The old image used to explain this is a wooden barrel made from uneven staves. The barrel can only hold water up to the height of the shortest stave, no matter how tall the others are. Plant growth works in the same way. If potassium, phosphorus, and calcium are present but nitrogen is too low, the whole system slows at the nitrogen line. For many home gardens, especially beds that have produced heavily through spring and early summer, nitrogen becomes that short stave. Vegetable scrap digestate is one way to return part of that missing nitrogen quickly. The method is simple in principle, but it requires restraint. Soft green scraps are chopped or crushed, placed into a bucket covered with water and kept submerged so fermentation and decomposition can begin evenly. After several days to 2 weeks, depending on temperature, the liquid becomes strong enough to use only after heavy dilution. That last phrase matters more than anything else in this section. Only after heavy dilution. This is where many gardeners ruin the method. They smell the strength of the liquid and assume strength means power, then pour it directly onto weak plants as if they are giving medicine. But concentrated digestate can burn root hairs, overwhelm the soil, and create exactly the stress the gardener was trying to solve. A rescue feed should never become a second injury. The safer approach is to treat vegetable scrap digestate as a concentrated extract, not as water. It should be diluted until it is weak, mild, and applied only around the root zone of established plants. It should not be sprayed on leaves, especially not in the heat of the day, and it should not be poured directly onto seedlings with delicate root systems. Used correctly, however, this liquid can provide a useful nitrogen push when a plant has stalled but still has living roots. The change is usually not theatrical, and it should not be promised as resurrection. But over several days, a plant that was pale and still may begin producing stronger new growth. The lower leaves may not recover because damaged leaves rarely return to perfect health, but the top of the plant can start moving again. That is the sign to watch. Not whether the old damage disappears, but whether new growth improves. This distinction is important because many gardeners misread recovery. They stare at the yellow leaves, waiting for them to turn green again, and assume the treatment failed. But plants often leave damaged tissue behind and invest their energy in new leaves, new roots, and new flowers. Recovery usually appears at the growing points. In that sense, vegetable scrap digestate teaches the gardener to look forward rather than backward. It also reveals something larger about the household itself. Every week, the average kitchen produces soft green waste that still contains plant nutrients. When that waste leaves the property, the garden loses fertility that could have returned to the soil. When even a portion of it is redirected into compost or liquid feed, the cycle begins to close. The goal is not to create a smelly bucket for its own sake. The goal is to stop treating nutrient-rich material as garbage. Onion peel water gives a gentle mineral extract. Fermented rice water feeds the microbial system. Vegetable scrap digestate addresses the hunger signal directly when nitrogen has become the limiting factor. But many struggling plants do not suffer from one missing nutrient alone. A tomato may need potassium for fruiting, calcium for tissue strength, magnesium for chlorophyll, and microbial food to keep the soil active. A pepper may stall because several small deficiencies have stacked on top of one another. For that kind of weakness, gardeners often reach for a mixed tonic. And the fourth liquid feed is the most misunderstood of them all, because nearly every ingredient in it has been exaggerated, misused, or explained incorrectly somewhere on the internet. The fourth liquid feed is the one most likely to attract attention because it sounds almost too simple to be useful. A banana peel. A few used coffee grounds, a crushed eggshell, a small pinch of Epsom salt, a spoonful of blackstrap molasses. Taken separately, each ingredient looks ordinary, and in many homes most of them would be thrown away before the day ends. But together, they represent something important. Not a miracle formula, but a small collection of common deficiencies that often appear in tired garden plants at the same time. This is why the mixture has become popular among gardeners. It feels complete. The banana peel brings the strongest emotional promise because most gardeners now associate banana skins with potassium. That connection is real, although it is often exaggerated online. Banana peels do contain potassium, and potassium matters enormously in the garden because it helps regulate water movement, flowering, fruit development, and the transport of sugars through the plant. A tomato plant short on potassium may still grow leaves, but its fruiting can become weak. Flowers may drop, fruit may stay small, and the plant may struggle to move energy from the leaves into the parts that actually become harvest. But a banana peel buried whole beside the plant will not solve that problem quickly. Like onion skins, banana peels must be broken down before their nutrients become useful. In a liquid brew, especially one supported by microbial activity, that process begins faster than it would in dry soil. The next ingredient is coffee grounds, and this is where one of the most persistent gardening myths needs to be corrected. For years, gardeners have repeated the idea that coffee grounds make soil strongly acidic. That claim is only partly true when discussing fresh, unbrewed coffee. Used coffee grounds, the kind left after making coffee, are usually much closer to neutral than most people expect. Their real value is not that they turn the garden acidic. Their value is that they add fine organic matter, small amounts of nitrogen, and a texture that soil organisms can gradually work through. In a liquid feed, they contribute less like a chemical dose and more like a mild organic support for the microbial system. Then come the eggshells. Eggshells are often described as an instant calcium fix, especially for tomatoes suffering from blossom end rot. But this is another place where internet gardening advice becomes too simple. Eggshells are made mostly of calcium carbonate, but large pieces break down slowly. A shell dropped into the soil today may still be visible long after the plant that needed help has finished the season. That does not make eggshells useless. It means they must be processed properly and understood honestly. Finely crushed or powdered eggshells can contribute calcium over time, especially in biologically active soil, but they should not be treated as an emergency cure for every fruiting problem. Blossom end rot is often connected not only to calcium in the soil, but to water movement inside the plant. If the plant cannot move calcium steadily into developing fruit because watering is inconsistent, adding more calcium alone may not fix the issue. This is exactly why the kitchen cocktail must be treated as support, not magic. Its fourth ingredient, Epsom salt, requires even more caution. Epsom salt is magnesium sulfate, and magnesium sits at the center of chlorophyll, the molecule that allows leaves to capture sunlight. When a plant truly lacks magnesium, the symptom can be striking. Leaves begin to yellow between the veins while the veins remain green. In that specific case, a small amount of dissolved Epsom salt may help. But Epsom salt is not a universal green-up trick. If the yellowing comes from nitrogen shortage, root damage, overwatering, disease, or iron deficiency, magnesium will not solve the real problem. Repeatedly adding it without diagnosis can even disturb the balance between magnesium and calcium in the soil. This is where the better gardener slows down. Not every yellow leaf means the same thing. Not every weak plant needs the same feed. And not every kitchen ingredient should be added simply because it sounds natural. The final ingredient is blackstrap molasses, and it may be the most important part of the mixture, not because it feeds the plant directly, but because it feeds the microbes that make the brew active. Molasses contains sugars and small amounts of minerals, but its real role is to wake up the microbial process. When added to a bucket containing banana peel, coffee grounds, powdered eggshell, and water, it gives bacteria and yeasts an energy source. Those organisms begin breaking down the ingredients faster, turning a passive soak into a living extraction. Without molasses, the mixture may still release some nutrients, but it behaves more like scraps sitting in water. With molasses, the brew becomes more biologically active. That is the difference between a slow soak and a fermenting tonic. A careful version of this mixture does not need to be complicated. A chopped banana peel, a small amount of used coffee grounds, a very finely crushed eggshell, a tiny pinch of Epsom salt only when magnesium deficiency is suspected, and a spoonful of blackstrap molasses can be added to water and left for several days with a loose cover. When the liquid begins to smell earthy or lightly fermented rather than rotten, it can be strained and diluted before being applied to the soil around established plants. The word diluted matters again. A mixed brew contains several active materials at once, and more is not better. A weak plant does not need to be overwhelmed. It needs to be guided back into balance. Applied too strong, even a natural liquid can irritate roots or create nutrient imbalances. Used properly, this fourth feed works best not as an emergency medicine, but as a broad support during stressful parts of the season. Early fruiting, heavy flowering, or recovery after heat. It carries potassium from the banana peel, mild organic material from the coffee grounds, slow calcium from the eggshell, possible magnesium from Epsom salt when needed, and microbial energy from molasses. That combination explains why gardeners are drawn to it. It feels like the whole kitchen turning back toward the soil. But even this mixture is still modern compared with the oldest liquid feed on the list. Long before banana peels were common in grocery stores, long before coffee filters sat in kitchen bins, and long before gardeners debated Epsom salt online, farms relied on a darker, older source of fertility. It came from animals, and when handled correctly, it became one of the most complete liquid feeds ever used in agriculture. The fifth liquid feed is older than every modern gardening aisle. Before synthetic nitrogen, before plastic fertilizer bags, before brightly colored bottles promised instant growth, farms relied on a much simpler cycle. Animals ate grass, hay, weeds, grain, and crop residues. Their manure returned part of that fertility to the land. The field fed the animal, and the animal fed the field. It was not romantic. It was practical. For most of agricultural history, manure was not waste. It was stored, aged, mixed with bedding, composted, and returned to the soil because farmers understood that a farm losing its manure was a farm slowly losing its fertility. The liquid version of that old system is often called manure tea. The image is almost exactly what the name suggests. Aged manure is placed inside a porous sack, an old cotton pillowcase, a burlap bag, or a mesh feed sack, and lowered into a bucket of water like a giant tea bag. Over several days, the water pulls out soluble nutrients while the solid material remains contained. The result is a dark liquid feed that can carry nitrogen, phosphorus, potassium, trace minerals, and microbial life in one simple extract. But this is also the feed that demands the most respect. Fresh manure is not the same thing as aged manure. Fresh droppings can contain too much ammonia, too many salts, weed seeds, and pathogens that do not belong near edible crops. Used carelessly, it can burn seedlings, contaminate leaves, and create more problems than it solves. That is why the old rule matters. Use aged or composted manure only. Chicken manure tends to be the strongest and is usually richest in nitrogen and phosphorus, which makes it powerful but easy to overdo. Cow manure is gentler and more balanced, often valued for improving soil structure over time. Rabbit manure is famous among gardeners because it is milder than many other manures, but even then, making tea from aged material is the safer path. The preparation should stay simple and cautious. A small amount of aged manure goes into the sack goes into water, and the bucket sits for several days while the liquid darkens. When the tea is ready, it should be diluted until it looks like weak iced tea before it touches the soil. That color is not just a visual detail. It is a reminder that the goal is not strength. The goal is availability without injury. A weak plant already under stress does not need a concentrated flood of nutrients. It needs a drink the roots can handle. Manure tea should be applied at the soil level, around the root zone, preferably when the day is cool and the soil is already slightly moist. It should not be sprayed over edible leaves, and it should not be used carelessly near harvest on crops where the edible part touches the ground. This is where practical gardening and old knowledge meet modern caution. The old method works because it extracts fertility from a material farms have used for thousands of years. The modern warning matters because we understand food safety more clearly now than many gardeners did in the past. Both truths can exist together. Used correctly, aged manure tea is one of the most complete feeds on this list because it does not focus on one narrow deficiency. It brings a broad spectrum of fertility into the root zone, while also reinforcing the biological life of the soil. It is not as clean as onion peel water. It is not as mild as fermented rice water. It does not have the kitchen charm of banana peels and coffee grounds. But it carries the oldest lesson in agriculture. Fertility is not created by buying more. Fertility is maintained by returning what the system has already produced. And now, the 5 feeds begin to make sense together. Onion peel water is the quick amber extract, a gentle mineral drink made from something most kitchens throw away. Fermented rice water is the microbial wake-up call, feeding the invisible life around the roots rather than the plant directly. Vegetable scrap digestate is the nitrogen rescue, useful when green growth has stalled, and the plant still has the strength to respond. The kitchen cocktail is the broader support, combining potassium, mild organic matter, slow calcium, possible magnesium, and microbial fuel into one careful tonic. Aged manure tea is the old farm method, a complete liquid feed drawn from the cycle between animals, soil, and plants. None of them is magic. None of them can revive a plant whose roots have already rotted away, whose stem has dried completely, or whose growing point is dead. A dead plant is dead, and no honest gardener should pretend otherwise. But many plants that look finished are not truly finished. They are stalled. They are hungry. They are trapped in soil that can no longer deliver the right support at the right speed. And that is where these liquid feeds matter. They work faster than burying scraps whole because the transformation has already begun before the material reaches the soil. Water extracts minerals. Fermentation wakes microbes. Digestion releases nitrogen. Dilution turns strength into safety. The principle beneath all 5 methods is the same one that ran through older farming systems for centuries. Waste is only waste when the cycle is broken. The onion skin, the rice water, the bruised vegetable, the banana peel, the coffee grounds, the eggshell, the aged manure, none of these materials are useless. They are nutrients caught between one life and the next, waiting for the gardener to return them to the system. That does not mean every garden should be filled with random homemade brews. The best gardeners are not reckless. They observe first. They look at which leaves are yellowing, whether the soil is wet or dry, whether roots are alive, whether the plant is trying to push new growth, and whether the problem is hunger, stress, disease, or poor drainage. A liquid feed is only useful when it answers the real problem. But when the diagnosis is right, even a small homemade feed can change the direction of a struggling plant. Not always overnight, not always dramatically, but enough to turn decline into recovery. And that is the quieter truth hidden inside this story. The cure for a weak garden is not always farther away. It is not always sealed in a bottle, measured in a factory, and sold under a bright label. Sometimes it is already passing through the kitchen every day, unnoticed because modern life has taught us to separate food from soil, waste from fertility, and gardening from the cycles that make gardening possible. So the next time a tomato begins to yellow, or a pepper stops flowering, or an old zucchini seems to lose its will in the heat of summer, pause before reaching for the shovel. Look at the plant more carefully. If the roots are still alive, the story may not be over. And somewhere nearby, in a jar of amber onion water, a cloudy rice ferment, a bucket of green scraps, a small kitchen brew, or an old manure tea steeping quietly in the shade, the garden may already have what it needs to begin again.